Hello, I'm Dr. Shepard. I'm the exercise physiologist here at Marshall University, and we are in the exercise physiology laboratory. We do research here on metabolism, and one of the questions that I often get asked is what substrate or what the person is using for energy at different intensities of exercise. Many of you probably in fitness centers have seen charts on the wall indicating that at very low heart rates you would be working in a fat burning zone. So what is this fat burning zone? Are those charts any good? Do you actually burn more fat by working at a lower intensity and a very low heart rate? If so, one of the trade-offs of that is that you are probably working at such a low intensity that you are not gaining any fitness because of a lack of biological adaptation, because the exercise is too easy. So first thing we're going to do here is I'd like to talk to you about the fat burning zone concept, how it is calculated, and the erroneous indications that those charts give you at your local fitness center. And then because they are not having you exercise at the appropriate intensity, I would like to go ahead and explain to you how to do your own calculations in order to burn the highest amount of fat for energy during any given exercise. So let's go ahead and start that. I'm going to transfer to my office and we're going to look at a PowerPoint and discuss those issues. So this is the type of chart that you typically see in your local fitness center, and this chart is used by many people in the fitness center to determine whether they're working hard enough to gain cardiopulmonary fitness. And there's another zone here in the yellow that indicates that if you are working at heart rates in this zone, then you would be burning high amounts of fat during that particular exercise. So the chart is set up to where the beats per minute heart rate is over here on the y-axis and your age is on the x-axis. So if you are 40 years of age, you can go up into the yellow fat burning zone and go over to your left, and the chart will tell you that you need to work between 120 and 130 beats per minute in order to stay in this fat burning zone. Now, what do we mean by a fat burning zone? Well, while you are on the treadmill, on the bike, or whatever the modality may be, when you're actually doing the exercise, does your body use higher amounts of fat or higher amounts of carbohydrate for energy? It turns out that the easier the exercise, the more fat you burn. The harder the exercise, the more carbohydrate that you use for energy. So these charts then are correct in that if you are working at a low intensity, the body uses more fat for energy. However, their calculations and their zones are erroneous, and that's what we're going to talk about here so that we can get you at an optimal amount of calorie expenditure, at the same time get cardiovascular benefit, but also be burning a maximal amount of fat during that exercise bout. The first thing we need to do is be able to calculate our maximal heart rate. Maximal heart rate is the heart rate that you would achieve if you were working at maximal exercise just before you would be so fatigued that you could no longer continue. Then that would be your maximal heart rate. Now, maximal heart rate, or the heart rate you can achieve, is not a function of how fit you are. It is determined by your age. So let's look at the calculation here. And you see the age in the calculations, and the reason is that your maximal heart rate is associated with how old you are, not how fit you are. Now typically you have used or have heard about the equation of 220 minus your age. That equation is falling out of favor. It is much less accurate than this equation, for instance, 207 minus 0.7 times your age. And the range of error associated with 220 minus your age is much greater than it is with this equation. So I recommend highly that you convert over to the 207 minus 0.7 times age. So let's look at that calculation. Unfortunately, I am 64 years of age, so I'm going to use that age, and we're going to take 64, multiply it by 0.7 and get 44.8. That will then take care of this part of the equation. Then we're going to take that and subtract it from 207, and that's going to give us a maximal predicted heart rate of 162 beats per minute. So that's how you calculate your maximal heart rate. And remember, how fast your heart is able to go is not changed as a result of you getting fit. It only changes as a result of you getting older. So if we were to put my maximal heart rate on this chart, then we would see that 162 is where this white line is. Now, if we look at for my age of 64 and go up to the fat burning zone, right here, you would see that I would be working at a very low heart rate, about 105 beats per minute. And that 105 beats per minute, this heart rate here, is only about 64% of my max heart rate. So here's my age, 64. Go up the chart to the fat burning zone, go over to the left to the y-axis, and you will see that I'm in the fat burning zone at about 105 beats per minute. Alright, so at that 105 beats per minute, if we were to look at the percentage of max heart rate that is in that fat burning zone on the chart, then 105 beats per minute divided by my maximal heart rate times 100 indicates that at 105 beats per minute and in the fat burning zone, I would be working at 64% of my max heart rate. Alright? So now, here's the 105 beats per minute. Now I'm in the sweet spot of the fat burning zone according to this chart at my age. And again, you can see my max heart rate is 162. Now the research that has been done is very clear as to the type and intensity of exercise that increases and gives you maximal fat utilization during the exercise. So that's what this line is, that if you work out at 50% of your maximal capacity, and we call that VO2 max, or percent of VO2 max, that is the percent of the maximal oxygen your body can take up in milliliters for 1 kilogram of your body weight. If you work and go through 50 all the way up to 85% or so of your maximal heart rate, you can see that there's an optimal level of intensity that will give us the maximal amount of fat utilization. And that is going to be at about 63 or 64%, but not of your max heart rate. It's 64% of your VO2 max. So where the folks are making their mistake is they're thinking that the percent of max heart rate is the same as the percent of VO2 max, and that is not even close. As a matter of fact, your percent of max heart rate is about 15% lower than your VO2 max. What we want to do is work out at 64% of our VO2 max. Well, you're not going to have a metabolic cart there, but you will have a heart rate monitor. So how is it that you can use your heart rate to determine what 64% of your VO2 max is, and therefore get the maximal amount of fat utilization? What we have to use is something called the heart rate reserve calculation. The heart rate reserve then is equal to the VO2 max in terms of percentage. If we are at 64% of our heart rate reserve, then we are very close to being at 64% of our VO2 max. And if that is the case, then when you look at this chart, you're going to be right in that sweet spot. And we need to know what heart rate will get us to maximal amount of fat utilization during any given exercise intensity. So let's do the calculation for heart rate reserve. Step 1, find your max heart rate. Remember, that's your 207 minus 0.7 times age. Step 2, determine your resting heart rate. So put your polar heart rate monitor on your Fitbit and lay down in a supine position for 5 minutes or so in a comfortable environment, and then observe what your resting heart rate is. Step 3, use the heart rate reserve formula. And here's the formula. You take the fractional intensity that you want to work at, and that's our 64%. And you multiply that times the amount of heartbeats you have left over beyond your resting heart rate, and that's called heart rate reserve. So that would be your max heart rate, that's your 220, your 207 minus 0.7 times age, minus the resting heart rate, multiply that times your 64%, then add your resting heart rate back on. Now let me give you an example for me. Because of my age, my maximal heart rate is predicted to be 162 beats per minute. I measured my resting heart rate at 55 beats per minute. I'm going to multiply to get that sweet zone and our fat burning zone at 64%. That's our fractional intensity. So we're going to use 64% multiplied by our heart rate reserve, which for me is 162 minus 55. Then we're going to add our resting heart rate back on, and that gives us, instead of a heart rate of 105, it gives us a heart rate of 124. So you can see the difference in the chart here between 105 and 124. Now if we look at our 105 for 64 years of age, that puts us in the fat burning zone according to 64% of our max heart rate. That is too low. We want 64% of our VO2 max. Using heart rate reserve, that gives us 124. Now let's see where that puts us. According to this chart, that puts us in maximal cardiopulmonary benefit, but above the fat burning zone. That's why these charts are incorrect. So you want to get a combination of a biological adaptation because you're working hard enough to get cardiopulmonary benefit, but at the same time get maximal fat burning from your exercise. And how you do that, again, is use 64% of your heart rate reserve. Do not use these charts because the charts are going to be too low. The heart rate's going to be too low. And when that heart rate's too low, that means that your exercise intensity is too low. That means you're not going to get a benefit from your exercise and you're not going to become more fit. So in this case, using heart rate reserve, 64% of heart rate reserve is going to put us in a zone where we get benefit from our exercise in terms of how well our heart works, how well our lungs work, and how well our muscles work. And those functional capacities now are going to increase because we are working out in that zone, but at the same time burn a maximum amount of fat in case the weight loss is one of the issues that you are concerned about. Now we are at the peak of our fat utilization as a result of doing the new calculation. Okay, so let's review very quickly. Do not use percent of max heart rate. Do not use the fat burning zone charge. Use heart rate reserve. Take 64% of your heart rate reserve, and that will put you in the zone that you want to be in for both fat utilization and improving cardiovascular fitness. So finishing up our discussion about the fallacy of the fat burning zone, I would like to talk with you just a little bit further about how the body understands and makes decisions about what substrate you'll be using for energy. Now when I say substrate, I'm talking about the body's going to be using either fat or carbohydrate for energy, and it'll be a combination of carbohydrate and fat, and it'll be in percentages. For instance, you may be working at 138 beats per minute and be burning 50% fat, 50% carbohydrate. Now in general, the lower the intensity, the lower the speed and the grade is on the treadmill. As an example, the more fat that you'll be using for energy during that exercise. The higher the intensity, the more the body has to gravitate toward using carbohydrates for energy. Biochemically, it's very complex for the body to use fat for energy. A lot of different enzymes are involved. The enzymes are slow. Fat has to be transported from underneath your skin to the muscle cell. It has to be transported across the muscle cell. There's a lot of different carriers involved. There's a lot of different enzymes, and therefore it's a very complex system by which you use fat for energy. All of that takes time. It turns out that you have carbohydrate already in the cell that you are using for the exercise. It's called glycogen. So you have carbohydrate in the cell that's going to be doing the muscle contraction. It's already there. It doesn't have to be transported from one place of the body to the other. You're only using 11 enzymes total to use that carbohydrate for energy. Therefore, it is much quicker. And now you can take the carbohydrate and convert it into energy of muscle contraction much more quickly than you can when you use fat for energy. Therefore, the more intense the exercise, then the faster you're going to have to convert chemical energy into the mechanical energy of muscle contraction, and therefore you're going to have to gravitate toward the food stuff that can be used the fastest, and that would be carbohydrate. That is the reason why if you do low intensity easy exercise, you use fat for energy, but as the exercise gets harder, you have to use carbohydrate for energy. Now, the misconception about this is that if you do high intensity exercise, you won't lose weight because you're not using very much fat for energy. And that is totally incorrect. What causes you to lose weight is you are tilting the thermodynamic equation by expending more energy than you're taking in. And if you expend that energy with high intensity exercise and use carbohydrate for energy to do that, you're still expending high amounts of calories, and therefore you will still lose weight. Eventually, all of that weight will come from fat, because what happens is the body is using fat for energy to replenish the carbohydrates that you've been using during the exercise. Secondly, the amount of fat that you would lose during one exercise bout is so small, it is very very little amount of weight in fat weight is lost in any given one workout. So across an entire month of working out every day for an entire month, the amount of fat weight that you're going to lose is going to be determined by the caloric deficit as a result of the exercise, independent of whether that exercise is low intensity or high intensity. Therefore, if you do low intensity and you're in this so-called fat burning zone, then you will not get as fit. If you do high intensity, you will still eventually lose your weight in the form of fat weight, but you gain the cardiorespiratory fitness that you want to achieve. Therefore, my recommendation is do higher intensity exercise, higher heart rates. Don't worry about what you're using for energy during the exercise, because that in a shorter period of time you will be expending more calories at a higher intensity, and eventually that is going to culminate into fat weight loss anyway. I hope this helps. I hope it clears up some of the misconceptions out there, and maybe allow you to understand a little more about what I call the fallacy of the fat burning zone. So this is Dr. Shepard at Marshall University and Marshall University Exercise Physiology Research Laboratory, and it's been good to be with you, and I hope this helps.